Hey everybody, Mr. Fuke here. This video is going to be part 2 of our angle addition postulate lesson. In part 1, you should have already gone through the idea that two adjacent angles can combine together to form a third larger angle. Part plus part equals whole is a good way to help you remember that. But in this video, we're going to talk about what happens when the word bisect is used. In certain cases, sometimes an angle will be bisected by another ray, and that creates some additional thoughts and processes we need to work on. So, what is an angle bisector? By definition, it is a line that splits an angle into two equal angles. That equal is such a key word, okay? That's going to be important for us in our equation creation in just a few moments. So, bisect, again, means to divide into two equal parts. So, what we're looking at here, there are essentially two ways that we can set up equations in this situation. So our equation strategies, and this will seem very familiar because this is the exact same way we did this with the segment addition postulate when we were introduced to the word midpoint. So if you have these two angles, these two smaller angles, those are essentially our halves here, right? They're equal to each other, so they're half of the whole thing. So one of the ways we can set up an equation is we can take one half of the angle and set it equal to the other half of the angle. So that's one strategy we're going to use, same as the segment addition postulate. The second option is if you were given one of the halves, so let's say you were given this bottom half, and then you were given the measure of the entire angle, we can also set up an equation where we double the angle that is half, and so we multiply it by 2, and we would set that then equal to the whole. So this video is going to look through examples where we're going to use the half equals half philosophy, and also the 2 times a half equals a whole. So let's look at some problems. For the first chunk, we're going to use this idea here that ray EF is going to bisect DEG. So again, just to remind ourselves what's happening here, the EF, I'm going to highlight here in red, that is the angle bisector. Now the drawing may not look like that, the drawing is not to scale. That's okay. We still are going to follow the rules that are given to us here. So DEG, angle DEG, which is this one here in blue, is the entire angle. The angle being bisected means that DEF, that's this angle here in green, and the other angle, FEG, are the same. They are equal to each other. So the green and the gray are equal. Notice I put a little arc symbol that represents how we measure an angle in degrees, and the little dash is to tell us that those are equal. So in the first question here, it tells us that DEG is 88. Now remember, DEG is the whole angle, okay? So the entire angle together is 88. FEG is half of the angle. So if we know the whole angle is 88 and we know FEG is half, all we would have to do is take that 88 and divide it by 2, and so FEG in this scenario would be 44. Let's look at a different what if. What if now FED, so that's one of the halves, that's one of the smaller parts, okay, is equal to 27, what would GED be? So GED is going to be the whole angle, that's the entire angle. So in this situation, because we know 27 is half, we would have to just multiply this by 2, and that would give me that the total angle here would be 54. All right, 2 more examples. We're going to use the same drawing. We're just going to bring it down here again so you can see it. DEF, so DEF, once again, that's one of my halves. And DEG is a whole. So DEG is the whole. Now in this case, because it's algebra based, we're going to actually have to set up an equation for this one. So because DEF is a half and DEG is a whole, we can't set them equal, but going back to our equation strategies idea, you can always take half of an angle, multiply it by 2, and it will always equal the whole angle. And that's what we're going to want to do here. We're going to take 2 times my 3x plus 1, put that in parentheses, and we're going to equal it to 5x plus 19. So when I solve this, we're going to get 6x plus 2 equals 5x plus 19. I'm going to move through the solving fairly quickly. So if you do need some review of how to solve an algebraic equation, please let me know. We can talk individually about that after you're done the video. So x is equal to 17. Now, still the same drawing. We're going to use it one more time for this example, and then we're going to try some other ones where you're going to get a chance to see how you do. DEF, so that's going to be one of my halves again. Okay, that's half of the angle. And then FEG, so FEG, that's this one, is the other half. So in this scenario, since I know what each half is written as an algebraic expression, we can do half equals half. And like I said, we now just have to solve this for x. So we'll subtract the 2x from both sides. We're going to get 3x minus 3 equals 15. You're going to add 3 to both sides. You're going to get 18. And then when I divide that, we're going to get x equals 6 here. There's one more problem I'm going to show you. One more we're going to go through together. And then after that, we're going to do a couple in this video where you're going to try, and then I'll have a full solution written out for you. So let's go ahead and move on to that. All right, this is the last one I'm going to do with you together, and then you're going to try the next few. So once again, we have EF is bisecting DEG. So you need to have this word bisect being used in order for us to use the ideas that I'm teaching in this video. So once again, we have FEG. So that's this bottom half here. So we're going to say half. And then FED is the other half. So just like the last example we just did together, if we have two halves, what we're going to do is set those halves equal to each other. And then once again, we're going to solve. So subtract 2x from both sides. That would give me 4x minus 7 equals 41. We're going to add 7 to both sides. So that's going to give me 48. And then lastly, we're going to divide by 4. So dividing by 4 here on both sides, we get x equals 12. Now, what makes this problem different than the last couple we've done is that I don't want to just solve for x. I specifically want to find DEG. Now, what makes this challenging is we don't have anything to plug into for DEG, but what I do know is that DEG is a whole. And so if I can find either FEG or FED, remember, you can take any of your halves, multiply it by 2, and it's going to equal the whole. So why don't we go ahead and let's just find, I don't know, FEG. So FEG, we're going to plug that in. It's going to be 6 times 12 minus 7. So when I do that, and you can use a calculator, or if you got the mental math, you can do that as well, we're getting 65. So since this 65 is considered half of the angle, in order to get the whole now, we would take 2 times 65, which is going to give me an angle of 130. So the measure of angle DEG will be 130 degrees. So keep that in mind as you're doing these examples and as you try these last few in our notes. So to wrap up, I have 3 examples you're going to try now. I'm going to scroll to this one first. So now we're looking at a new angle here. BX is the bisector of ABC. So I want you to pause the video here, try the problem out, and then in a few seconds, the answer will pop up on screen. Now, hopefully you've tried the problem out. So just as a highlight here, once again, ABX, the drawing really is to help you indicate whether it's a half or a whole. So in the ABX, that's going to be half of the angle. XBC is the other half. So that tells me we're going to set them equal. Solve this and we get x equals 5. The angle we want to find is ABC. However, this is the whole. So in order to figure out the whole angle, we probably should know what one of the halves is first. So I went ahead and chose to be ABX as that number. So ABX ends up being 25 degrees. That's half of the angle. So as we know, if we want to find the whole, we're going to take 2 times that half, and that's going to give me the 50 degrees. So ABC, the measure of ABC, should be 50 degrees. Let's try another. Here is number 3. Again, pause this video, try this out, and let's see what you come up with as a final answer. Welcome back. So when I labeled this, ABC in this situation is going to be my whole. That's the entire angle. And ABX is going to be half my angle. So I'm going to take my half, which is 24, multiply it by 2 to equal the whole. So 2 times half of something will always equal the whole thing. Solve this equation, we get x equals 15. Since this is all we were looking for, we are done the question. Last question for this video. Once again, I'm going to have you pause this video and then try this problem out. And then in a few seconds, I'll have the answer for you. I got an answer of x equals 2 here. So much like the last example, we were given a whole, we were given a half. And so what we're going to do here is we're going to take the whole thing, 4x plus 16, and we're going to set it equal to, I'm going to do it blue here instead, my half. My half here is 3x plus 6. make sure we're multiplying that by 2, and most importantly, make sure you're putting that within parentheses here. So we're going to multiply 2 in parentheses 3x plus 6 and solving at x equals 2. So that will conclude this part of the angle addition postulate. There is still a third part, and we'll work on that at a later time. But for the time being, go back and check this video out for any additional explanations that you may need, and good luck with your practice. Thanks for watching.